Hello. In this video, we're gonna continue our study of judgment proof problem. So we're gonna study 4.1.3, page 17 in my lecture note. In this part, we're gonna think about monetary care situation. Up to here, we assumed care cost was non-monetary. Care cost was non-monetary up to here. So this means, so remember, injured's asset is U, and if something goes wrong and injured has to pay, in this case, we subtract this liability cost from injured's asset, but remember we didn't subtract monetary cost, care cost from injured's asset. So in this case, when when there was judgment proof problem, so U is lower than H. So in this case, we say this part is gonna be gone. So in injured's bank account, nothing is left, but we still have minus X in injured's payoff. So this was considered as non-monetary. This was considered as non-monetary utility loss or disutility. This was our assumption up to here. And now what if care cost becomes monetary cost? So for example, in our driving example, X is increasing, so injured is more careful in driving. So in this case, we can imagine that he's gonna have a more expensive black box for his car, for example, or he's gonna install a better safety system in his car by paying more money and something like that. So here, in this section, we're gonna imagine care cost is monetary, so we have to subtract care cost directly from injured's asset. In this case, let's think about strict liability. Let's think about strict liability, and let's ask if we can achieve social optimum under strict liability. As usual, under strict liability, injurer is going to try to maximize his own payoff. He doesn't care about society. Injurer cares about himself. So injurer is going to try to maximize his own payoff. So injurer's payoff in this case is, so we can calculate injurer's expected payoff here. So either there is accident or there is no accident. If there is no accident, what is injurer's payoff? He has asset U, and we're gonna subtract care cost. And that's it, he doesn't pay in this case. If there is accident, then in this case, we can write down injurer's payoff as using this formula. We can write down injurer's payoff in this way. So what does it mean? It means, so for example, So here we have to subtract care cost directly from Injur's asset. So Injur initially has asset U dollars, and we have to subtract care cost from his asset. So U minus X is now Injur's available asset for compensation. So he can pay liability out of U minus X. So if U minus X is lower than H, then he cannot fully compensate the victim. So there is judgment proof problem. So in this case, we say there is judgment proof problem. So judgment proof problem now becomes slightly different. So remember in the previous section, we had judgment proof problem if U is lower than H. So in that case, we had a judgment proof problem if Injur's initial asset is lower than liability cost H, because we didn't have to subtract care cost from Injur's asset. But now, judgment proof problem condition is different because we have to subtract care cost from Injur's asset. So after subtracting care cost, Injur's remaining amount of money is U minus X. So he can pay only up to U minus X. So U minus X available amount of asset is lower than liability cost H, then Injur is judgment proof, and in this case he just pays whatever he has and that's it. So in this case, so if something goes wrong and there is an accident, and if this inequality is true, in this case Injur's payoff is gonna be 0. So Injur's payoff is gonna be 0. So this red part over here is gonna become 0 under judgment proof problem. Otherwise, so Injur's available asset can so Injur's available asset U minus X is bigger than H, then Injur can fully compensate the victim. So in this case, Injur's payoff under accident is gonna be this part. So this red expression over here is gonna be either 0 or this expression, depending on whether Injur's available asset is bigger than or lower than H. Therefore, so if there is judgment proof problem, so available asset is lower than H, in this case, Injur's expected payoff is gonna be so if something goes wrong, there is an accident, then Injur lose everything, so his payoff is gonna be 0. And you can notice that there is no minus X over here. When care cost was non-monetary in the previous section, if there is an accident, then Injur is left with no asset, but he still has minus X utility cost in his payoff, but it's not here because care cost becomes monetary in this section. So if there is judgment proof problem and there is an accident, Injur's payoff is just equal to 0. and no accident, then injurious asset is gonna be u minus x. If there is no judgment proof problem, then if something goes wrong, so there is an accident, injurious payoff is this much. So injurer has initially $U asset, and we're gonna subtract carry cost, and we're gonna injurer is gonna fully compensate the victim. So we're gonna subtract liability cost here. If there is no accident, then injurer's payoff is U minus X. So in this case, we can simplify expression. Then we get this expression. And when there is judgment problem, injurer's expected payoff is given by this blue expression, and if there is no judgment proof problem, injurer's expected payoff is expressed by this green expression. And one thing we must be careful here is look at these conditions for judgment proof problem. So remember, injurer is gonna choose the level of X. So injurer has to choose how much to be careful. So injurer is gonna choose the level of X. So here, X is chosen by injurer. So suppose, so injurer's asset U is bigger than H. In this case, injurer is gonna choose small amount of X, so injurer is not that careful. In that case, X is gonna be very small, so we subtract X from U, then U minus X is gonna be here. Then in this case, available asset for compensation is bigger than H, so there is no judgment proof problem. But what if injurer is really careful, so X is really big? In that case, U minus X is gonna be very small. Then in this case, there is judgment proof problem. So here what we can see is when care cost becomes monetary, injurer can choose to be judgment proof or not judgment proof. So this is very important difference between this section and the previous section. So when care cost was non-monetary, whether injurer is judgment proof or not judgment proof is given, because if so when X was non-monetary, whether judgment proof or not is given, because U and H are just numbers. So if U is bigger than H, no judgment proof problem. If U is less than H, there is judgment proof problem. So it is given to injurer. But now, when care cost becomes monetary, injurer has to choose whether he's gonna be judgment proof or not judgment proof. So if injurer is not that careful, let's say, so X is very small, so we are here, so X is very small, so X is here, and we are here, U minus X is bigger than H, then injurer choose to be not judgment proof. But injurer choice of X is very big, so U minus X is very small. Then in this case, injurer is judgment proof. So in this case, we can say integer choose to be judgment proof. So important point here is when x becomes monetary, integer is going to choose. So integer is going to choose to be judgment proof or not judgment proof. So this is very important point in this section. Okay, so in this kind of situation, then what's gonna be the choice of integer and can you achieve social optimum under strict liability? This is the question. So let's see. So remember, integer's problem here is, so integer wants to maximize his expected payoff. So he wants to maximize his expected payoff, and his expected payoff is this. So this is integer's expected payoff, and he wants to maximize his expected payoff by choosing x. And in the process of choosing x, maybe integer is gonna be judgment proof or not judgment proof depending on his choice of care. And if you look at this problem, it's not easy to think about this problem directly. So we can modify this problem by using our knowledge from microeconomics. So I'm going to turn this problem to another problem, which is the same problem as this problem, but the new problem looks simpler in the sense that we know how to deal with that kind of problem. So I'm going to write down another problem, and I'm going to show that this new problem is exactly the same problem as our problem. So in this problem, we want to minimize this expression by choosing x and d, and we have constraint and this is our constraint. So this problem is like a consumer's utility maximization problem. So remember, consumer's utility maximization problem, we had something like this. So consumer wants to maximize his utility. So let's say there are only two consumption goods. So consumer wants to maximize utility. Let's say Q1 and Q2. So let's say Q1 is apple, Q2 is banana. So consumer has to choose how many apples to eat and how many bananas to eat. And of course, we have budget constraint for consumer's problem. So consumer, let's say consumer's income is I, and consumer is going to spend P1 times Q1 amount of money for purchase of apple, and P2 times Q2 amount of money for purchase of banana. So this right hand side indicates total expenditure, and the left hand side I is income. So this budget constraint says expenditure must be equal to consumer's income. So this is consumer's utility maximization problem, and we know how to solve this kind of problem. So how do we solve this problem? Typically we draw graph. So budget constraint, budget constraint is a straight line, and we draw indifference curve. So we draw indifference curve and the budget constraint, and at some point indifference curve is tangent to the budget constraint, and this at this red point we get our solution for consumers utility maximization problem. So this is how we solve this kind of problem. So we can use the same technique to solve this problem. And before we move on, let me show this new problem is actually the same problem as this blue problem. So this blue problem and red problem are the same problem. So instead of solving our original problem, we're gonna try to solve our new problem. So why are they same? Let's say, so if u minus x is lower than h, so in other words, we have judgment proof problem for integer. In this case, in our original problem here, so look at this blue problem. So this is our original problem. So from here, we can calculate that. So under judgment proof problem, we know that integer has payoff 0 under accident. And there is no accident, then integer's payoff is u minus x. And under the same condition, look at our new problem. So in our new problem, look at the constraint. H is bigger than u minus x. So if h is bigger than u minus x, if you compare h and u minus x, u minus x is a smaller number. So this expression it means between these two expressions, h and u minus x, we have to choose the lower one. So this expression is gonna be u minus x. So it means d is equal to u minus x. So let's put u minus x here instead of d. Then so u minus x. So in this case, this expression is so px times u and plus 1 minus px minus px so minus px times x so minus x. Okay. So then look at this expression. So let's compare. So px. So we have px times u plus minus px times x. Then here, this is u minus. So let me rewrite this expression. So if we rewrite this expression, we get. So if we rewrite this expression, we get this expression. So u minus p times x times u and minus. Okay. So what we get? This blue expression comes from our original problem, and this green expression comes from our new problem. So from our original problem, we want to maximize this expression. In our new problem, we want to minimize this expression. So if we compare these two, so one thing we know from mathematics is we want here we have minimization problem, but we can turn this to maximization problem if you put minus sign in your objective function. So let's put minus sign. Then this is our new problem. Then, so we want to compare blue problem and the purple problem, and we can see that these two problems are the same in the sense that these two problems give us the same solution. So why? So look at these two problems. So same maximization problem, and this part is the same. Blue part is the same. The only difference between these two problems is that there is u in our original problem. But this u is a number. So when you want to solve this kind of problem, what do? We take derivative and set it equal to 0. So when you want to solve this problem, so you take derivative and set it equal to 0. So in this process, this number u, this is just a number, so it disappears. So when you take derivative, you get the same equation here. So you get the same equation here, so solution must be the same for both problems. So this blue problem and purple problem, they are the same problem in the sense that they give us the same solution. So what we saw here is, in this case, so when integer is subject to judgment proof problem, our original problem and new problem are the same in the sense that they give us the same solution. Then now, what if there is no judgment proof problem? So in this case, so we can do the same. So in this case, in our original problem, what do we get? So integer's expected payoff is, so when there is accident, integer's payoff is u minus x, so remaining amount of asset, and we subtract liability cost h, and if there is no accident, integer's asset is u minus x without paying for liability. So so if we simplify this expression, we get this expression from our original problem. So integer wants to maximize this expression. What about in our new problem? So in our new problem, look at the constraint. So in constraint, d is equal to this expression. So if u minus x is bigger than h is smaller, so d is equal to h. Then we're gonna put this to our objective function. So put our objective function. Then in our new problem, objective function becomes, this is our objective function in our new problem. So in new problem, we want to minimize. So in this case, this is our original problem, and this is our new problem. And as we did before, we can, let's say, we can turn this problem to minimization problem by putting minus sign in objective function. So this is our new problem. So if you compare these two, they're the same minimization problem, and x, same, x times h, same. The only difference is there is a number here. But as I said before, when we want to solve this problem, we have to take derivative and set it equal to 0. In this process, number minus u is gone, so it does not appear. So we get the same equation when we take derivative, so same solution. So solution is again same. So again, our original problem and new problem, they are the same problem in the sense that they give us the same solution. So we can see that in our previous page. So remember this blue problem here. This blue problem is our original problem. So we want to solve this problem, but it turns out this purple problem is the same problem as this blue problem. So instead of directly solving blue problem, we're gonna deal with this purple problem. And why did we change our problem to this new problem? Because this new problem looks simpler in the sense that we know how to solve this kind of problem by drawing graph. So now let's think about this purple problem. So our problem here is, so remember under strict liability. So our question here is, can we achieve social optimum under strict liability? So Injera wants to solve this problem. So Injera wants to solve this problem. So this is problem we have to solve now. First, we can think about drawing budget constraint. So remember, in consumers utility maximization problem, how do we solve this problem? First, we draw budget constraint in the graph. So we can do that here. So let's think about drawing budget constraint first. Okay, then how does budget constraint look like here? So let's say, so x is here, d is here. So in our utility maximization problem, in the x-axis we have Q1 apple, y-axis we have Q2 banana. So we're gonna use this terminology here. So imagine here x is like an apple and d is like a banana. So we have to choose x and d here. And so if suppose x is very small, so in this case, so we want to draw budget constraint here. So let's say, so we want to draw budget constraint here. So let's say, U is here and H is here. So initially, Injera has enough asset to cover his liability cost. So let's assume this. And let's think about this function. So suppose we want to draw this function in this graph. So this is a function of one variable, x, and u is just a number. So if we draw this graph here, it's gonna be a straight line with a slope -1. So if I draw here, it's gonna be this straight line. So u is also here. So if I want to draw this graph u minus x graph here, it's gonna be straight line. Y-intercept is u, x-intercept is also u, and slope is -1. N. Let's see. So if x is very small, suppose x is very small. So let's say x is here. So x is very small. So in this case, so remember, this is graph of u minus x. So when x is very small, we can see that u minus x is bigger than h. But when x becomes large, then here we can see that u minus x is lower than h. So when we want to draw graph for this constraint, d is gonna be equal to h when x is very small. Why? Because I'm gonna put number 1 here. X is very small. So when x is very small, we can see that u minus x is bigger than h. So u minus x here is bigger than h. So h is lower than u minus x. So d is gonna be equal to h when x is very small. So d is equal to h when d is equal to h if x is very small. But let's say x is now big. Number 2, look at this point number 2. Now x is really big. And at this point, we can see that u minus x is here, but h is bigger. So in this case, d here is, now u minus x becomes lower than h. So d is going to be equal to u minus x if x is a big number. Therefore, if I draw graph here, d is equal to h. How do I draw this graph? d is equal to h. So imagine, so xy here. So if you want to draw y is equal to 5 in this graph, how does it look? It's gonna be a flat straight line at 5. So it's exactly same here. So d is equal to h. I want to draw a graph for this. Then it's gonna be, it's going to be a straight line. So as long as x is small, so up to this point right here, so up to, let's say, number 3, up to point 3, x is small, so u minus x is bigger than h. So in this case, d is equal to h. But after point 3, now x is big, so h is bigger than u minus x. So there, I have to draw this graph. D is equal to u minus x. So this is like I want to draw graph for something like this. So I have this this red straight line in this picture. So this means if I draw a graph for this constraint, it has a kink here. So it has this red shape of graph in our picture. So imagine that this red graph is something like a budget constraint in consumer's utility maximization problem. So now we are done with drawing this something like budget constraint. So now what we have to do is we have to draw something like indifference curve, right? Because when we study consumer's utility maximization problem, we draw budget constraint and then we draw indifference curve, right? So what we did here is we drew something like budget constraint in our picture, and now we're gonna draw next we're gonna draw something like indifference curve, and then we can talk about the solution to our problem.